joining. First up, Nick Martelaro. So Nick is an assistant professor at Carnegie Mellon's Human-Computer Interaction Institute. His research seeks to augment designers' capabilities so that they can best leverage human capacity and computation to solve society's toughest problems. His research approach integrates cutting-edge technologies, but always with a foundational understanding of designers and how we think and act. Nick's work spans design domains, blending hardware, software, and interaction design. Before moving to the HCII, he was a researcher at the Digital Experiences Group at Accenture Technology Labs. Nick graduated with a PhD with mechanical engineering from Stanford's Center of Design Research, where he was co-advised by Larry Leifer and Wendy Ju. And second up, Niki Kittur. Aniket Niki Kittur is a professor in the same institute, Human-Computer Interaction Institute at Carnegie Mellon University. His research on AI augmented cognition looks at how we can accelerate knowledge acquisition and innovation by partnering human and machine intelligence. He has authored and co-authored over 100 papers, 17 of which have received Best Paper Awards or honorable mentions. Dr. Kittur is a Kavli Fellow, has been inducted in the Chi Academy, has received an NSF Career Award, the Alan Newell Award for Research Excellence, major research grants from NSF, NIH, Google, Microsoft, Bosch, and Toyota, and his work has been reported in venues including Nature News, The Economist, Wall Street Journal, NPR, TechCrunch, and the Chronicle of Higher Education. He received a bachelor's in psychology and computer science at Princeton and a PhD in cognitive psychology from UCLA. Everyone, please give a warm welcome for Niki and Nick, and I'll pass it over to Nick for the first set of the presentations.
Great. Thank you, Brandon. All right, let me just hit play here and screen share with audio. Great. All right. So, Brandon, yeah, thank you for the introduction. Niki and I are excited to be here to talk to Autodesk today. So the reason why you're getting both of us is because we are collaborating a lot today around this idea of utilizing generative AI to enhance human creativity, especially in the areas of engineering and design. We are both really motivated by sort of a lot of large-scale problems that we have where innovation is critically needed. These are some of the grand challenges from the National Academy of Engineering, providing clean water, solar energy, zero waste manufacturing. These are big problems, and we are trying to think about how do we help enhance people's ability to solve these problems. People have been talking about utilizing AI to help with these, and I think Niki and I are excited about those possibilities, but we are also very bullish on humans or humans with AI doing that. Here, there's actually this is a nice quote that we've used to motivate our work, that many businesses, and basically everyone, is trying to foster more innovation in their work. They are trying to get their companies and their people to be more innovative. It's going to be a big part of their business growth and about part of solving challenges for the future. However, most companies are not particularly enthused with how performant they are in their ability to sort of innovate. So how to help people innovate more? Well, in 2025, that probably means Gen AI, or at least companies everywhere, people everywhere are thinking about Gen AI and its potential abilities to augment our capabilities and enhance our innovation abilities. And Niki and I are also interested in this. So as researchers, we're interested in exploring this and figuring out, what can this technology do and how can we really best leverage it? At this point, it's sort of the genie is out of the bottle. We're not going to be kind of putting generative AI back in. It's kind of permeating everywhere. It is everywhere. And while it may feel very hyped, there are also a lot of real potential. There's a lot of real potential here. And so one of the things that we are interested in exploring is how do we actually harness this in a controlled way, such that we avoid some of these issues of, for example, misinterpretation, where it'll create anything sort of for you. In addition, one of the things that we've been seeing coming out of recent research from across the HCI community has been that language model-based generative AI can actually change the way we think. And in some cases, that can be not so great. So for example, this paper here suggests that LLMs can actually lead to more homogeneous design, basically more homogeneous ideas, which in some ways kind of makes sense if you think about the way LLMs are generally, structured. They're utilizing known data, and they're synthesizing but predicting sort of next tokens. It kind of makes sense that maybe things start to look pretty similar. Um, this, however, could have an impact on people, though. The more that we use this, the more our thinking potentially becomes more aligned with these language models and basically with these large systems. And so Niki and I are quite interested in understanding and doing more research to figure out, well, what's going on here with the way that people think when they're interacting with these tools? And then eventually, how can we actually build systems that don't that avoid these issues and actually help to create more opportunities for them to be more creative? Again, that sort of idea of unleashing their creativity as opposed to hampering it. So I'll dive now into some work that I've done. And actually, this is work that is hopefully near and dear to all of your hearts. Actually, in 2021, my team was really interested in generative design from Autodesk and thinking about how people learn to collaborate and work with these tools. We were super excited about the opportunities that, I wouldn't have to sit there and do geometry manipulation anymore. I could basically convey intent about my design goals, and then the system would be able to generate, in this case, of course, as you all know, mechanical structures. And so we wanted to observe people. We wanted to observe designers who were generally pretty seasoned in mechanical engineering using a generative design. We gave them sort of a task, which was a mounting bracket for a ship. This is very much aligned with what Autodesk generative design is good at. It's something that also a mechanical engineer, even within a half an hour, should be able to set up the problem and get a somewhat reasonable result. Interesting thing though, we noticed that people really struggled. And I'll say that I don't think that this is about the interface. This is not about sort of how the generative design tool is created. Actually, it was really interesting. Most people had a lot of trouble setting up the problem. Actually, only one person sort of came up with a design that would meet all of the requirements we gave, both the structural load requirements and then the part volume requirements along with the tool clearances. And so this was really surprising to us. Also to note here, our participants were PhDs in mechanical engineering, mechanical engineering consultants that we had hired from an online, Upwork platform. So these were people who were, in theory, should be able to do this type of problem. And so, really this kind of got us thinking, well, maybe designing with AI is hard, but that's just because design is hard, right? The AI maybe isn't entirely making it harder. It's that actually thinking through all of your loads, all of your constraints, all of the tool clearances, what materials you're going to select, all of that up front, as opposed to kind of the more traditional way that we may work when we're doing these things, where we're actually building up over time. And we're building up a solution where often we're working with geometry and taking things away and then making it work in our head. That's hard. It's hard to kind of think of these. And so we got interested in thinking about, all right, well, could we help people to kind of think better while they were doing their design? So this sort of spawned this question of, can AI support deeper design thought? And I'll say that again, this was back in 2021. So we're just at kind of like the earlier days of language models and their sort of ability to generate text and be able to sort of have conversations with us. But we were thinking that actually conversational interaction could be a really great way to do this. This is actually how designers, it's how we work with each other. If I'm having a trouble, I'm going to go down to my friend a couple desks down. Hey, could you check this out? Hey, could you help me think through this problem? And so we thought, hey, what if we were to create sort of this digital design partner that would help you in your thinking process, not in just kind of helping you with that geometry creation, but in thinking through what are all the considerations. And so that's what we set out to do. And this is actually work that we ended up exploring with a team member, Yi Wang from Autodesk San Francisco, a former team member in the research division, where we basically explored this idea of what we call metacognitive support agents. So these are AI agents that support you thinking about thinking, like helping you think through how you're thinking about your problem. And so again, right, we think that this is really interesting and useful for generative design tasks because this is where you have to think through all of those constraints, all those considerations, such that you can set up a solver, and then, computationally, you can generate multiple design options, which you can then evaluate. But there's a lot of challenges with that. There's actually a bunch of cognitive challenges when you're doing this type of work. For example, intent formulation, actually forming the right specifications, conveying those things. Sometimes we don't often have language for it. It's easier for us to sketch an idea or to simply set up something than it is to type it out or speak it out. Problem exploration, that's another thing. We actually have to think through our problem and think through all the considerations. However, one of the challenges is that as we use AI more, sometimes we can offload some of our problem solving and our problem exploration to an AI system, and we're not sure that's great. And the last one is outcome evaluation. So thinking through sort of the outcomes that we have and that you generate. And of course, from a generative design perspective, you can generate tens, dozens, and dozens of ideas. Now you have to actually select among them. And so that's what we sort of set out to do. Again, in this prior study, we found that most designers had a bunch of trouble with creating these parts. And so what we did was we actually we had experts who would kind of help people along. So this was a human-human study, and we discovered a couple of strategies that they used. One was that thinking aloud and helping them sketch, especially recommending to people to use a free body diagram. You'd be surprised, actually, at how many mechanical engineers didn't think, like, I should draw a free body diagram immediately. And yet when someone asks you to do it, you go, oh yeah. And then they basically solve their problem. Actually, it was one of the keys to unlocking being able to solve this problem was drawing that free body diagram. In addition, we also saw that a lot of our experts would break down sort of this interaction through a series of questions and reflections. They would ask people, hey, is that what you thought was going to happen? Like, what do you think might be going wrong here? Tell me what constraints you're kind of considering. Are you sure about that? And so those things were really helpful for people. And so what we did was we created a set of sort of concepts for new design agents that we would then test to see if any of these strategies would sort of help the designers kind of unlock their ability to solve this problem and actually, achieve pretty good results. So, for example, one of them is asking this idea of reflective questions, and that was an agent that we called Socrates. Actually, Socrates was set up in somewhat of an annoying way, actually, using the Socratic method. It only ever asked you questions. If you asked it anything, it would ask you a question back. It would never answer a question from you. It would only ask questions. But we wanted to really explore this idea of how good questions can actually unlock people's thinking. Another agent, this one was a little more, oh, let me be a little more of a partner here. So Hephaestus would help you plan. It would help you with thinking through sketches and recommending, for example, doing a free body diagram and then helping you think through that, and would also make certain suggestions around the problem. So for example, thinking about different considerations based on, say, the maritime nature of that. It's a ship bracket, so it's in a maritime environment. What considerations might you have? Now, I will say that we tried to keep the questions generally fairly open so that the AI required to drive this wouldn't have to be that smart. Now I'll say all of these were driven by people on the back end, although using AI to sort of help them. So it's sort of a Wizard of Oz scenario. And a third condition that we used actually was we brought in some experts from Autodesk. We actually met some folks from the generative design team, and we brought them in, and we had them act as sort of this AI agent. So they were hidden behind the scenes, and we told them, hey, don't give away the answer, but ask questions, give suggestions, try to help the person think through things. And so this was another case. And then finally, we had another, we replicated sort of that no support condition. Now, we found that support definitely helps. Actually, again, as we had saw before, if people don't have support, like no one seems to, I don't know, people really couldn't solve the problem. And I will say, like the brief wasn't that complicated. And it's just hard. It's a hard thing to do. And all the people who were supported had much better results. Now, not everyone had perfect results, but people did have significant improvements based on the questions. And interestingly, people were helped in sort of different ways. It kind of depended what strategy would help what person at what time, which actually makes this type of interaction really complex. Actually, a way to think about it is the right support at the right time can really unlock someone's thinking, but the right support at the wrong time might not. They might be like, whatever, I don't have time for this. And of course, the wrong support at a good moment may not be useful as well. And so to give you an example of what this looks like, here's an example of a reflective agent asking questions to kind of help with precise problem exploration and intent formulation.
When specifying the bolt clearances, how do these impact the assembly and servicing of the bracket?
So this part it won't be serviceable. You can't fit any type of, that's on a hex head, well, then you need a socket. So you need enough clearance for the socket. So I will go back to edit model and so we're gonna have tool clearance and.
So that question sort of, again, hey, have you thought about the serviceability of this? Which on the one hand is, somewhat of an intelligent question to ask. On the other hand, it's not maybe that. Like one could imagine a checklist of this, like here's all the considerations that I need to kind of go through. But it is the kind of thing that will help you to say, actually, I realize I need to get some tool clearances in there, and I need to use the tool clearance feature of the generative design system. I'll show one more example here. This is an agent providing a sketchboard to help someone think through their free body diagram. Again, this was really, really helpful. Basically, we could go through and have someone think through basically all the forces and all the directions. And this, in many, many ways, unlocks people's thinking. We've been thinking about this more, this idea of sort of diagrammatic thinking, which is very common, of course, in engineering and design, but how can AI agents maybe facilitate more diagrammatic thinking to help people actually think through their problems as opposed to staying completely focused in, say, their CAD tool of choice. So, overall, we found that these sort of metacognitive support agents had a positive impact. And open-ended questions and thought externalization aids can really help designers with thinking through and overcoming a lot of the cognitive challenges they have in intent specification, problem exploration, and then eventually when they do have options, actually thinking about those options. However, there's some more open questions we have. So for example, how much are you asking people things versus are you telling people and maybe giving hints? Also, we found that there may be people who might over rely on these agents. Like they kept asking, some people kept asking like, hey, can you do more for me? Can you do more for me? There was even a really interesting case where sometimes people would also get thrown off by an agent, say asking a question, hey, could you walk me through your loads? There's nothing in that question that says you're wrong or you're right. It's a pretty standard. Just walk me through the forces you're putting on this. And then people would actually sometimes go, oh, well, I don't know. And oh, maybe this, and then they'll tie themselves in knots and actually go in a completely wrong direction. It was actually, I'll have to say, as we were watching this, it was really hard to do that because to watch that sometimes where you're like, no, you were fine. We just wanted you to like clarify that. And so we have some interesting thoughts about how to potentially maybe avoid those issues. So now I'll quickly talk about another project, and this kind of gets us now into some of the work where Niki and I started collaborating. And it gets back to this idea again, I'll bring that slide up, of LLMs leading to more homogeneous design. This is something that we were like, hey, is that this could be a problem? And we're actually doing some work along with the Toyota Research Institute, who is also interested in this. They've actually found that their designers are trying to use AI, but also they're finding, their designers get in ruts, right? They get stuck on certain things. And so this led us to try to explore how might we be able to kind of break design fixation and break sort of this homogenation that we see when using these generative systems. So this is work, again, with the Toyota Research Institute, and then Niki and I have been working on this together with our students, David and Hyunsu. And this is a sketching tool that actually utilizes analogies and generative AI to help break people out of sort of fixated design ideas. And so, the general problem here is that right now designers are trying to use AI to help them. Oftentimes in, let's say doing industrial design sketching, when they're provided with abstract words, and this is really common. This is how it actually works in automotive companies. Design a car that evokes a sense of protectiveness. So, okay, what does protectiveness mean? All right, well, maybe I'll try to throw it into Midjourney. And what people do is they talk to it. They've told us it's sort of like, all right, I'm going to hit the slot machine, right? And they say this is a protective car, realistic studio lighting. And what they end up with is cars that look like other cars. Actually, if anything, they get cars that look like competitor cars, which is really not good. And so we thought, okay, well, this is not really how designers work. So how do we actually build systems that maybe support them in a way that is more like how they work? And so the three challenges that we wanted to kind of focus on were sort of that designing through prompts is generally unnatural, and it doesn't fit well with their sketching process. Most text-to-image models struggle with generating abstract concepts that they're often given. So for example, a protective car, a car that represents freedom. But that actually is a technique that teams use to kind of generate more novel designs. And then finally, it's also pretty hard to build on the designs, right? You just get totally formed images. And it's hard to kind of work with that. So we developed a new sketching tool, leveraging ideas that Niki and I had been thinking about around utilizing analogies and sort of this sort of collaboration with an AI system. And this is called Inkspire. Let me actually show you a demo of Inkspire.
Inkspire allows users to design products by sketching with an AI partner. First, I'll specify the product. For example, I would like to design a chair. For my design concept, I would like the chair to give a sense of fluidity. We can click on Inspire to ask for some analogical inspirations for a fluid chair. I see some neat suggestions. Let me try a couple of them. I like the waterfall concept. Let's design a waterfall chair. On the sketching canvas, I can see a shadow underlay. This underlay displays the AI-generated design in a more abstracted, sketch-like form, which I can use as scaffolding to build on top of the AI design. For example, I like this curve of the waterfall. Let me trace over it to guide the AI to use this. I also like the waterfall puddle under the chair. Let me sketch this too. Each new sketch stroke generates a new design iteration. On the left, I can see how my design has evolved over time. I'll continue sketching to iterate my design and guide it to my vision. Here is my waterfall chair created with Inkspire.
So from here, the main idea is really this utilizing of sort of these analogical concepts, which we're generating with a language model, And then what we've done is we've modified ControlNet. So ControlNet's a sketching model to control text-to-image models where you can do pencil sketches. We've modified it a bit so that it can actually handle just single strokes and still do something with that. And then we can generate sort of every time the designer lifts their pen. And so this idea is they can kind of go back and forth with the AI. What this allows them to do is kind of generate lots of design ideas within and get a lot of inspiration within a really short amount of time. And what they're doing is they're doing this primarily through sketching rather than trying to prompt engineer their way into a different image. So we tested this with designers, and we found that in general, most designers had a better interaction with this, at least moving them in many different directions than if they were using more of a prompt engineering based method. Even if they had the ControlNet, they could do the pencil sketch. So for example, here's a transparent chair that then becomes a glass chair, a silicon chair, and then a jellyfish chair. And you can see that they're building up on that sketch on sort of the shape that they're getting. And then from there, this is sort of compared to what other designers did, where they're sort of creating a very high resolution sketch, and then they're prompt engineering their way into trying to get it to look the way they want. So this is a chair, Lancia style iconic forms. And so we found that sort of this use of analogy and this rapid iteration can actually be really powerful. And so this is now a place where Niki and I have started to think more deeply about this question of how can we better leverage analogies in our design process as a way to unlock creativity. And at this point, I'll hand it over to Niki to talk a little more about the work we've been doing there.
All right, thanks, Nick. Let me. All right, so I think you just saw in Nick's demo of Inkspire how analogies can help unleash creativity compared to the process where designers often get fixated in the first idea or even the second idea that they come up with. And I wanted to kind of take a step back and talk a little bit more about analogy as a fundamental force for unleashing creativity and how we can start to harness that better using some of the new AI tools that we have today. And I wanted to really take a step back. And when I say step back, I mean, like, let's step back like 10,000 years and be like, all right, what is it that has driven the success of us as a species in being creative, whether it's, coming up with new inventions, art, technology, you name it. And one of the quotes that I really like from Manuel Castells is that it's our ability as humans to creatively accumulate and recombine knowledge and information in non-routine ways. And I think this idea of like recombination is really central to how we can support creativity today. How do we recombine knowledge and information in non-routine ways? And one of the most effective ways that we've found over those 10,000 years has been analogy, but taking ideas from one area, one domain, and applying them to a very distant, very different domain. So, Chrysippus was looking at a stone thrown into a pond and saw the rippling of the waves on the water's surface and made the connection to, hey, maybe sound actually works this way. The Wright brothers actually used multiple analogies when they were designing an airplane, including a cardboard inner tube box sitting in their office, and they started playing with it, and they're like, maybe we can use sort of the shear force to design the steering of the plane in a very lightweight way. And so if we can help people with finding and recognizing and adapting these analogies to their own problems, we have the potential to really unleash creativity. Now, that's a problem. And why don't we do this more, right? And I want to give you an intuition of that. And it's actually this intuition is based on a analogy by Matt Might, who's looking at, so imagine this circle contains all of human knowledge. And you go to elementary school, you learn a little, you go to high school, you learn a little more, you go to college, maybe you get a degree in some, major, maybe you get a master's and you learn a little more. Maybe you go to graduate school and you start to get to the edge of knowledge and you read papers that are at that cutting edge and you start to do some work there. And once you get to that edge, you start to push and you push and you push, and finally this barrier gives way, and we call this a PhD. And yeah, no offense, I have one as well. Like this is, but this is good, right? This is good. This is how knowledge accumulates. And just think about, though, how hard it is for one person to reach that edge of knowledge, let alone push past that edge of knowledge. And now think about analogy and how things are growing. First of all, this edge of knowledge is not static. It's growing over time, right? As each person adds to it and pushes through it. And an analogy requires you to not just reach the edge of knowledge in one area, but you have to start looking at multiple areas. And there's probably lots of areas that you looked at that didn't have anything good there either. So in some sense, it's kind of amazing that we find any analogies at all because of how hard it is to just get to looking for them. It's kind of like finding a needle in a haystack. I can talk, my PhD is about analogy. I can talk about this for many times. So I'm gonna cut this short to say, well, how do we actually help people then? How do we help people find these needles in a haystack? Because if we could, there's a lot of haystacks out there that there could be great needles that we could find things in. So there's lots of idea repositories out there. There's patents, millions of patents. There's billions of things out there online, design examples, web pages, videos, you name it. And just to give you one of my favorite analogies is actually the development of the Odon device. So for many centuries, a baby stuck in the birth canal has been a major problem. And the Odon device actually uses a technique for extracting the baby in the birth canal that the World Health Organization says has been for centuries this is maybe one of the largest advances. What I find really interesting about this is that it was not an expert who developed this. It was actually an Argentinian car mechanic who was watching a YouTube video for pulling a cork out of a bottle. It's like a party trick, and you put the plastic bag in and you inflate it a little bit, and then you can extract the cork out of that. And so this is an example of how if we could democratize this, if we could equip designers with millions and millions of potential inspirations from many diverse domains, we might be able to really accelerate the ability for us to make progress on those big problems that Nick was talking about. So I've been looking at this over quite a few years. So I'm going to really give you like a condensed version of what's been happening, but it's sort of a similar thing. We've been looking at how do we help people, equip them with analogies from unstructured data. Data that's just all out there. So I'm going to talk very briefly about we started looking at crowdsourcing, AI in the form of semantic embeddings, and then how do we apply that with now that we have LLMs and generative AI. And I want to do this because I think it'll give you a little bit of the intuition around kind of analogies and analogical thinking that maybe you'll be able to take, into your own domain and your own work and be able to apply this yourselves. So how does analogy work? We have many, many decades of work on analogy and how do people actually do analogies. And the way it works is pretty well known. Like, we take examples that are out there, we try to abstract them into some kind of like purpose. What is this thing trying to do and how does it do it? And then we take those to a new domain and try to generate ideas by applying them in those domains. So we're going to do a little exercise here where we're going to try to do this together. All right. So I'm going to actually use some examples from Quirky, which was a really fun idea, crowdsourced idea repository, almost like a design firm based on crowds. So one of the things they came up with was this idea of a rake, and it had this slider on it. So if you got the leaves on the rake all stuck, you could just push the slider and the leaves would all come off. So my first question to you would be, so then we also have this skewers where if instead of having to touch the, get the chicken and vegetables off the skewers, you can just slide that off. So my first question to you would be like, what purpose and mechanism do these two things share, like at a more abstract level, right? And so maybe you would think, okay, well, the purpose is that they're trying to detach two objects, right? So one's a rake and one's sliders. Those one's skewers. Those are really different, but really fundamentally they're trying to detach two objects, and the mechanism they're using is a movable slider that kind of goes across things, right? So now if you think about this, I'm just going to I'll give you like 20 seconds to throw in the chat. What are some other ideas where you need to detach two objects from each other that you can imagine using a slider for? And be as creative as you can. Just type into the chat anything you can imagine. The more ridiculous, the better. Ooh, chopsticks. Nice. Oh, that would be cool. Oh, yeah. Magnet stores, windows, zippers, many things. Good. Remove a tick with you can imagine a slider for removing it as maximally as possible. All right, I'll give you 5 more seconds. Any other ideas? Ooh, batteries from electron. I just had this problem. This is great. Okay, excellent. So we've all got our new startups here, right? But past that, right? Like now we have some idea of like the analogical process of like how do we go through this process of like abstracting things, and then now you have to think of like, where could I even find ideas for detaching two objects? How do I find those? Our memories are not well set up for that, actually. So that's a hard thing to do, right? You all had to do that. And then you have to think, how am I going to use this like slider idea in this? Like, does that even make sense for like removing a tick with a slider, right? So now again, you have a challenge of like, how do I apply this idea? And so these are things that I think AI can help us with. And we've been exploring this. And I'm going to tell you, first we looked at how do we do this with, if we take that AI and we actually just think of this as different people. Can we crowdsource this? Where instead of doing that whole process yourself, can we have different people doing all of these different parts of the process? And there's a lot of advantages in like having more ideas and separating them out between people. I'm just going to kind of give you a very quick essence of this, which was that, we had people do this in sort of a crowdsourced way. And then we rated the quality of the ideas they came up with. So for those of you who aren't that familiar with creativity research, right? It's often really hard to say like, hey, is this a creative idea or is this not a creative idea? And so there's a lot of work that's shown that these are some pretty good ways of kind of distinguishing creative ideas from less creative. And there's 3 dimensions here, like how novel or how new is this idea? How useful is it? Does it solve the problem you're trying to solve? And is it actually something you can make? Like I could make a chair made out of gravity that's like really novel and like really comfortable, but it's probably hard to manufacture a chair made out of gravity right now, right? So we also use, tend to use multiple judges who have design and engineering experience and have a lot of inter-rater reliability. And what we found in this case was this. So here on the y-axis is the quality or the creative quality of objects. What we found is that if compared to people who are just kind of directly given these examples, like the sliders and the skewers, if we gave them the schemas, if we gave them these abstract versions of things like I did with you, people were much more effective. They came up with, across many studies, we found they come up with more ideas. Their ideas are better. They, think through the ideas more, and they're more diverse and more novel. So that's something that we learned from the crowdsourcing studies. And here's an example of one that I wish someone would actually build for my camera. It's like the lens cap leaves. It basically takes the idea of like a vegetable steamer that kind of folds up, and when the lens cap is open, it acts as a sunshade, and when it's closed, it acts as a lens cap. So these are the types of ideas that we might get out of something like this. All right, so let's think about moving from crowdsourcing to AI. What could we do now that we have access to things that can think, not on the order of just, oh, I can give you churn through hundreds of ideas with crowdsourcing. I can churn through thousands or millions of ideas with AI to find those needles in haystacks. So the first work we did, this is work with Daphna Shahoff's group at the University of Jerusalem. We were looking at how do we use some of these new, semantic embedding tools to do analogy. And one of the fundamental problems here, whether it's LLMs, whether it's, embeddings, whatever you do, these things are trained on, as Nick said, co-occurrence and prediction of next word, next tokens. And we're actually not looking for sort of surface similarity and next token prediction for analogy. We're trying to find things that are similar at a structural level, but very different actually at a surface level, right? So this is a very different kind of problem that we're trying to solve. And how do we solve it? We can't just, as Nick was saying, there's lots of examples of LLMs, and before us, we were looking at embeddings that fail at really kind of finding deeply different and novel and diverse yet relevant ideas. So one of the insights we had is that instead of trying to solve like really complex analogies, maybe all we need to do is to figure out two things. Can we take an idea and split it up into its purpose and its mechanism? So imagine you have a little yogurt maker machine, and it uses kind of heat and vacuum and a drum to accomplish that purpose. Can we automatically pull out the purpose of this as being, making energy in yogurt, and the mechanism is, well, it uses this vacuum cooled drum to actually do this? And once you have these things, now we can say, can we find other things that have a similar purpose but use a very different mechanism, so we can actually minimize the distance for the purpose and maximize the distance for the mechanism? And now you have something that can still work for, next token prediction, because these differences kind of are driven by that, but they're still giving you very diverse and novel but relevant things, because they're relevant in one dimension and they're very diverse in another dimension. So how do we do this? We generated a bunch of training data. We used some, at that point, Siamese networks to sort of train something to be able to pull out purpose vectors and mechanism vectors. And then we can use semantic embedding spaces on these two very different types of dimensions, a purpose dimension and a mechanism dimension, to find things that are close and far. And you can run this in reverse too, right? You could say, hey, what other things could I use this slider mechanism for, right? Which is kind of what we did implicitly. Oh, maybe I can use this for ticks. Maybe I could use this for doors, etc. And what we found is that if we gave people these analogical ideas, they came up with many more sort of good ideas. And if you look at them, they're very different than either giving them ideas that were sort of a straight next token, here's the most similar things, or just giving them random ideas. You might think, hey, what if we just give them random ideas? Well, it's not enough to give them random ideas. You actually have to have them be structurally similar to the problem that you're trying to solve. Here's an example. Let's imagine you're trying to come up with ideas for a cell phone case that helps you charge things. Very surface similar ideas would be like a cell phone battery or a case with GPS. Random ideas would be like, shampoo pods or dog meetup app. Like, I'm not sure how that's helping you solve the problem. Whereas in our case, we'd come up with things like USB tower, or my favorite, the human pulley powered generator suit, which someone still needs to make, I think. So that should give you a sense of how can we sort of take this idea of purpose and mechanism dimensions and use them to help drive analogy. What I showed you was sort of toy problems, right? Like these are like a cell phone, like consumer products. That's what we were looking at. We've also done this with engineering and more generally scientific papers and scientific domains. So this is work that ended up being something we followed up with Semantic Scholar and the Allen Institute for AI, which was around, can we take these same ideas and do them for real with can we build like almost like an analogical search engine, an interactive analogical search engine? This is where, my student Hyunsu Kang did this work where we mined 12 million scientific papers. We, basically did the same thing that I talked about, and there's a lot more machinery sort of involved in making all of this work at real time. And we gave these to people, we visualized these and gave these to real scientists and engineers to be like, take your own problems and try running this on them. And we looked at what kinds of things we gave back. And we actually took a probe of some of the ideas that came from kind of a traditional search engine, some that came from ours, and again, some random ones. And what we found was something very interesting, which was that they would often find things in the regular search condition that they could directly apply. So imagine that they were trying to, there's a heat transfer problem, and they had kind of a direct application would be like, oh, here's this new thermal metallic contact approach. And so they could say, oh yeah, I can see how I would use that. But most of the situations here they had already seen. This is sort of like the low-hanging fruit that they had already seen. So what we found was that instead, the analogical search led to what we call creative adaptation. So here's something that's very different. Here's a fin structure. This was for kind of a a nanomaterial situation. So they would look at this fin for dissipating heat and be like, yeah, but like, how do I do that at a nano level? And then they would kind of like that bell would go off, kind of like Nick was saying too, like, oh, actually, now that you've pushed me into this, what would a fin look like at a nano level? And then they actually said, that's interesting. I haven't seen something like that. So they take something, it mismatches a little bit because, it's not directly applicable, but they can transfer that themselves to their own domain. And they found that much more valuable. So here's a direct quote, right? What if we could design nanostructures that act like fins that convert heat to mechanical energy, right? So now it's not even just dissipating the heat, it's actually converting it to mechanical energy. And we found that the analogical condition led to much more frequent creative adaptation than the keyword condition, which was really much more around direct application. Okay, and this was true across lots of different situations of, these are like real scientific application, hyperspectral imaging, hydrophobicity, etc. All right, so we have some idea that we can find analogies that are potentially useful to people. But one thing that we learned when we were doing this was that we almost had to push people to get past the idea that, oh yeah, like those fins are interesting, but like, how do I use them for my own nanoscale purpose? Like, I feel like in many cases, they would have just, if we weren't sitting there with them, making them do that, they would have just kind of ignored it. They would have sort of thrown that useful idea away because it was too hard to transfer it to their own problem. So this is work that we did, again, with Toyota Research Institute. This came out at CHI just, a couple months ago. And the idea here was, can we actually go beyond just finding ideas to helping people with that transfer. And this is where generative AI becomes really, really valuable, not only in sort of more effective finding, but also in closing the loop to actually transferring those ideas. So the first part of this system, called BioSpark, was a system for generating ideas from nature that might be interesting inspirations and analogies. So let's imagine that we had a problem like we were trying to design a bike rack that would, hold your bike more securely and aerodynamically. What BioSpark will do is go out and find ideas from nature that might help with that problem. So you can see, and then it clusters all of these ideas together. So here we have, for example, maybe there's something around a, silk producing gland from a spider that you might be able to use. Or, maybe a silkworm or a butterfly, right? There's sort of a cluster of inspirations or mechanisms for doing that. Now you might say, well, how am I going to actually use that, right? And so now the key to BioSpark is really supporting that transfer. Now let's think about, I actually took, how would you apply like this mucus from a snail for lubrication and adhesion? How would you use that for a bike rack? And you can put that into LLM, and I did, and this is the result. How would you apply this? This was my prompt to design a better bike rack for your car. And here was the result. As you can see, it's not the best, I would say, right? Like a result for what I would actually do with the bike rack. So this is and you can fiddle with this, but let me show you how BioSpark solves this problem. All right, so in the BioSpark, what I didn't show you in BioSpark is that we have a pane for helping people think through the transfer of these ideas. So
inspirations for new ideas that may.
I'm going to just turn this off. So here you can see that it's already generated for us this idea of, okay, like maybe the bike rack can use a gel layer that can adapt to any size bike frame without any, without issue. And it's not just that, right? People can actually ask, well, okay, what's a good candidate for a hydrogel coating? And that might, like you're not going to put snail mucus on your actual bike rack. You're going to think about how you can use that idea with something that might actually work, and still be okay in the cold or when it's wet outside. And it will help you think through kind of different options here, and which ones might do better in which situations, different kinds of hydrogels or silicone things. And then we also help with things like, well, what are the trade-offs? Like, what are some pros and cons of doing this? And again, we're trying to help people, again, instead of just saying, take this idea and go with it, how do we help you think through all of the trade-offs and help you navigate that space where a lot of creativity is found in understanding deeply the constraints of the space and how you can find interesting patches and sweet spots within that space. And we found that, kind of at the end of the day, BioSpark users generated more ideas. They also generated more creative ideas. And we're using, again, this novelty, value, and feasibility with ratings by multiple design and engineering experts to show that the ideas they came up with were more novel, more valuable, and basically just as feasible as, or close to as feasible as the baseline condition. Okay, so I'm just going to end by mentioning that we're interested, and this is a connection. Part of the reason why we're here talking to you today is that both Nick and I are very interested in how do we move beyond the lab to understand real world impact? How do we, we really like working with real kind of engineers and designers who have problems. How do we help them with creativity? One example of a past project we've done in this vein is with Conservation X. So Conservation X is a nonprofit that puts on conservation challenges, innovation challenges. So they'll take, get $100 million to like try to improve conservation in the oceans, and then they'll put that out as a contest for people to submit ideas, and they'll help build through those help them through the process for the winners. So a challenge might be something like, how do we reduce microplastics in the oceans? We've helped them now design multiple contests where we take some of these tools for improving the creativity of ideas through analogies, and we actually build them into the contest. And there's a rigorous process where we give half of the teams our intervention and half of the teams are a control group. And we use the same judges that they normally use, and they go through the same contest. They get the same, all of the prizes are allocated just as normal, so that we can really see if these ideas are leading to more innovative and creative ideas, which is kind of the challenge they came to us with, saying, originally they said, we put out these contests, we're just getting these kind of boring, same ideas. And so what we found, our first contest actually resulted in significantly less creative ideas, which was, first of all, terrible, right? Like we've taken your money and we've resulted in less creative ideas. But I think it's a good thing in the sense that we are rigorously measuring what happens. Some of the most obvious things actually lead to negative results, right? And so we could take from that and learn what aspects were good and what aspects were bad. And that ended us, by the time we were finished with our set of studies, we could reliably create more kind of creative ideas as measured by novelty and usefulness versus kind of not using our system. And they're still using our system today. One of the examples that I think is really fun is, I'm not going to go into this now, but Werewolf.
What we do is actually we engineer proteins in the lab. We've identified
Werewolf, which is a company that takes proteins from things like starfish and uses them to create microfibers that don't have the same microplastics, but it can still have bright colors or are very flexible in ways that synthetic fibers would give you today. Okay, so the TLDR of really, I think what we're trying to do is we're trying to take creativity from a sort of like a lightning strike of serendipity to something that's more like a power grid. Like, how can we help everyone, all of the designers and engineers, be more creative throughout their process, integrated into their process, so that they're, making progress on those big problems that we talked about to begin with. So if you're interested, we're very, very interested in talking to you and working with you. Would love to find more collaboration opportunities. And there's a webpage with a little bit more details on what we're doing. And maybe I'll stop here and open it up to any questions. Thanks a lot, everyone.
Yeah, appreciate the presentations, guys. G, I saw your hand go up.
Oh no, I meant to clap.
Oh, yeah. Any questions out there? I know we're at time and there's folks have other meetings and things, but yeah, any quick questions as we wrap up here? And of course, after these sessions, we'll distribute the contact information and all that, so we can establish any communication. But Michael, I think you came off mute. Did you want to ask something?
I did. I think the Toyota account team would be really interested in connecting with you a little bit about what you did with Toyota research. And we just had Toyota out at Pier 9 last week. And so there's some interesting connections we could connect.
That would be great. We'd really like that.
Awesome. Thank you, Michael.
You're
We can
welcome.
follow up offline.
Thank you.
Any other takers?
I just always like to say anything that involves a bicycle, that was awesome. Orville and Wilbur, heroes. Well done. Great presentation.
Great. Thank you.
All right. Well, Nick and Niki, really appreciate you all joining us. I'm sure you'll be hearing from a few of us. But yeah, thank you for the time, and we'll stay in touch. Thanks, everyone, for joining.
Great.